Hello guys, welcome to 4.3 extension. So just a little bit after the section 4.3 in our book, but just before 4.4. So instead of getting it's short. Instead of giving its own section, it's just 4.3 extension. So we are working with areas of composite figures today. A composite figure is like this. It's a figure made up of triangles, squares, rectangles, and other 2D figures. It can be made up of many different 2D figures that we already know how to find the area of. So in order to find the area of a composite figure, we separate it into smaller figures with areas that we already know how to find. Then we find the sum, or we add up the areas of those two figures. So basically we're taking a larger shape, like this one, and we are going to break it into smaller shapes, find the areas of both those smaller shapes, and add them together. So looking at example number 1, we can break this shape, whatever you want to call that composite figure, into two smaller shapes. Now there's lots of ways you can do it. You can break it into a lot of different smaller shapes like triangles and one large rectangle. Or I in particular see this shape, my pen. If we were to take our pen here and draw a line straight through, we've now got a rectangle on top and a trapezoid on the bottom, and we know how to solve for the area of a trapezoid because we just learned that in 4.3. We already know how to find the area of a rectangle, so we're going to find the area of both, and we'll use one side for the area of rectangle, one side for the area of the trapezoid, then we'll add them up together, and when we add the two areas, we'll know the entire area of this composite figure. So we're going to use OSS like we know and love so well. Let me zoom in a bit on this area here. All right, so let's go ahead and get started using our red pen. Let's start with the area of the rectangle, so A of R. OSS, we know that the area of a rectangle is A equals length times width. Now if we look back at our figure, let's actually count our length and our width. So here's our rectangle right here on top. Our length is this side right here, and if we go ahead and count that, we've got 1, 2, 3, 4, 5, 6 blocks that we run through. So remember, not counting the dots, we're counting the actual grid lines. So we've got 6 units here, and if we count our width, we've got 1, 2, 3, 4. So let's go ahead and substitute in now. A equals 6 times 4, and solve. Easy peasy. A equals 24 units squared. Taking a look at our trapezoid down on the bottom, area of trapezoid. We're going to use OSS again. This time we've got area equals, and this might be one way that you do it, height times base 1 plus base 2, parentheses, all over 2, divided by 2. Some of you may multiply the top part there by 1/2, which is the same thing as dividing by 2. Any way you'd like to do it. All right, you've got our substitution now. We got to look back at our trapezoid and see what our bases and heights actually are. So I'm going to switch to my blue pen, looking at our trapezoid down at the bottom here. Our base on the bottom, we've got, let's move it over a tad, 1, 2, 3, 4, 5, 6, 7, 8. So we've got a base of 8. We already know our base 2 is 4. We see that up here with our rectangle. And now let's just take a look at our height. I see it runs through 2 grid lines. So pretty easy. We've got our height, our base 1, and our base 2 now. Let's substitute in. I should have been using blue this whole time. There we go. We've got A equals, we've got 2 for our height, times base 1, which is 8, plus 4, which is our base 2. Divide it all by 2. Go ahead and solve. Area equals 2 times 8 plus 4 is 12, divided by 2. We could go through and do 2 times 12 is 24, divide that by 2. Or I see here I can just cancel out these common factors on the top and the bottom, and I'm left with area is 12 units squared. So now that we know the areas of the two smaller pieces within our composite figure, all we can do is take this 24 down here, add 24, and then we can take this 12 right here, add 12, and we end up with A lovely 24 plus 12 gives us 36 square units, or units squared. And what we just found then is the area of this entire figure is 36 units squared. Now, one way we can check that is simply by counting those blocks. So let's go ahead and count our blocks, starting up here at the top. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I'm going to count full blocks down here. 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Then I see that there are two half blocks. They're exactly cut in half. That would be 25. Nope, 35. And then these two up here would be 36. So we've got a total of 36 square units. All right, let's move down to example number 2, our real life application. We are finding the area of the fairway between two streams on a golf course. Since it's black and white, it's kind of hard to see. This is one stream, this is another stream. And this is a golf course, so the fairway is just the area that you're golfing on between these two streams that we see here. So we're just finding the area of that funky figure, that funky shape, that composite figure. In order to do that, we need to take that shape and break it into two smaller figures. There's lots of ways you can do that. Lots and lots and lots. For me, one way that I see it is by taking this little area, this little piece off here to the side, breaking it off. We've got a triangle over here, a rectangle over here. That's the way we'll go ahead and solve it together. There are other ways you can solve this. You could cut it right here, and you'd actually end up with a 40 by 40 by 40 by 40 inch square, or yard square. You'd see that if you cut it right here, and then you'd have a trapezoid up top here. So you'd be using that trapezoid formula again to find the area. Whatever way you want to do it is fine. We should all end up with the same area no matter what. Like I said, I see it easily like this. I'm going to take this triangle and cut it straight off like that. So now I'm dealing with a rectangle and a triangle. Up here, start with my smaller piece. It doesn't matter which piece you start with. Let's find the area of our triangle. A of tri. Area of triangle. I don't want to say T because that could get confused with the trapezoid. So area of triangle, we know area equals 1/2 base times height. Some of you may have wrote this in as area equals base times height divided by 2, and that's fine. Area equals 1/2. I can see here that my base is 40. And my height is this length right here. Now, it doesn't tell me what that is, but what I can do to figure that out, look at this long line of the rectangle over here. Well, if this rectangle has a length of 70 yards, I know that this piece here is 40, so this piece right here must add up something plus 40 to give me an entire length of 70. So what number plus 40 gives me 70? Well, that must be 30. So that right there is going to be 30 yards. It's not a 6, that's a 0. So 30 yards. So I've got my base of 40, my height of 30. 40 times 30. Area equals 1/2. 40 times 30, or 4 times 3 is 12. 1200. Add those two zeros on. 1/2 of 1200 gives me 600 yards squared. And that's this portion right here of our triangle. Let's go ahead and find out what the area of our rectangle is. I'm going to switch to blue. Area of rectangle, or R. Scoot this over just a tad. Alright, so A equals area of a rectangle. It's not base times height. That's for parallelogram. It's very similar. We're just going to say it's length times width. If I take a look at my rectangle here, I've got my length. We already figured out was 70 yards. My width here is 40. A equals 70 times 40. 7 times 4 is 28. Add the two zeros on. 2,800 yard squared. Now what we can do is simply add up our two areas, bring down our 600, bring down our 2,800, and we end up with a lovely 600 plus 2,800. Give you a second to add that up. You should have 3,400 yard squared. Now, like I said, you could have broken that up a couple different ways if you would have rather kind of ignore this line right here. If you would have rather just cut the line right there, you'd have had a trapezoid up top, square on the bottom. You would have still end up with a total of 3,400 yards squared. All right, now what I want you guys to do is flip over your page, and you are going to be working on this activity here, looking at the picture of the arrow and determining the area of this figure. And you can do it with a partner. You can break it up into a variety of different shapes in order to solve this. And then I want you to try this problem down here with a rectangular patio. Some of you may remember this problem from the past. When you give it a try, you got to remember some of your percent problems, the formulas to figure out percent. So give these both a try, and best of luck to you.